All right, Module 2, Part 2. So now you're going to get into your own practice using this energy skate park. So this link can be found on the module right here, energy skate park link. Open it up in a new window. Now at the same time, you're going to go to the other part of the module, the assignment called Energy Skate Park Simulation. So this is your assignment for today. And yes, it is a bit longer. This will take you maybe 45 minutes to an hour. So you can type on it right in here, or if you want to see it full screen, you can click on that blue link. This is your copy, and it's in your Google Drive. Now I'm waiting for it to load, and I'm going to move it into my science folder and my Unit 4 folder. All right, you should do that too. It looks like I've already done that. But that's what you should do whenever you do one of these Google Cloud assignments. And I've actually already written on mine. That's a sentence starter for you. So this is a virtual lab using this skate park simulation. Now you've got a few options here. I want you to pick the first one. First thing I like to do on this game is choose my player, right? So choose whichever character you want to do. Of course, I'm going to choose the dog because I love dogs. And then we're going to do a few things. Let's put a grid on it. That's down here. Let's open up this. This is going to be a bar graph showing us kinetic, potential, thermal, and total energy. And then let's click on the pie chart. I liked as many graphs as possible so I really know what's happening. And then I want you to just pick up your skater, drag it to the topmost point of the track, and let it go. And now we're just going to observe. Notice what changes as the skater goes up and down and back and forth. The other thing is friction. So in real life, a skater wouldn't go back and forth forever. Eventually, it would slow down and stop. Friction exists along this ramp, and it also exists on the bottom of the skateboard wheels. Friction is the force that slows motion down, right? So if you just pushed off on a skateboard on a flat surface, eventually you'd slow down and stop, and that's because of friction. Friction works against the wheels, and it takes away some of the speed. Well, let's see what happens if we add friction here. Slide it up a little bit. So now we see some orange. Orange represents thermal, and thermal energy we know better as heat. So basically what's happening as the skateboard skates, it's slowing down a little bit, and there's some heat that's being created between the track and the skateboard wheels. And that is another form of energy. Eventually, all the total energy gets transformed into thermal energy, and there's no more kinetic and potential energy left. The skater has stopped. So we have one last section in your notes. I know you thought you were done with notes. I'm sorry, you weren't. So we got to add some vocab words. We already know that gravity is what's pulling the skater down along the track because it's pulling objects towards Earth. Now, what's new here is friction. So in your notes, you're going to define friction, and friction is the resistance of motion of an object relative to surrounding matter. I know that sounds complicated, but a simpler way to think of friction is it slows down moving objects. It slows them down if they are rolling on a surface, even sliding on a surface. It even slows them down if they're just falling through the air. Now, the rougher the surface is, the more friction it'll have. Think of it as walking on a wooden floor versus an ice rink. If you try and walk on an ice rink, you're gonna slip because it's slick, meaning it's smooth and there's less friction. On the other hand, you're probably not gonna slip on a carpet ever because there's a lot of friction. All right, now let's define thermal energy. Thermal energy is heat. And heat is produced whenever there's friction. And the best way to demonstrate this is taking your hands and just rubbing them together like you would if you were trying to warm them up. Why does that work? Because of friction. So this warms up the surfaces of your hands because as they move back and forth against each other, there's a lot of friction there. So thermal energy is better known as heat, and it's produced by friction. Okay, so we've played around with some of these different things on the energy skate park. You can also explore with gravity. Let's see what happens if I make there to be a lot of gravity. If there's lots, there's more total energy. I also still have friction, so the thermal energy is using up the other energies until eventually my dog stops. You can also turn gravity off, which is just as fun, especially if you do this. So I turned gravity up and down and made my dog fly. All right, so what's your assignment then? Other than to play around with that energy skate park, you're going to follow the directions on this procedure, okay? And you're going to answer questions wherever you see a blue line. And actually, I'm going to delete this answer and change it back to a blue line. So I want you to make your own observations. So starting with number 1, which we actually already did in this video, check the grid and the bar graph. That's this and this. And keep them open at all times, so just don't change that. And then explore the simulation. So try different tracks, try the gravity, try the friction, and write down your initial observations. As you go, the questions will get more specific and help you understand the concepts today. Now it is long. There's 12 directions with questions, and then there are 8 post-lab questions. You don't have to write in complete sentences. That's not important for your understanding at this time, but you do have to answer all the questions, okay? Everywhere there's a blue line, make sure you put an answer. Like I said, it might take you half an hour, maybe an hour, and that's why I gave it to you on our last class of the week. So you can work on it over the weekend if you'd like. Just make sure you get it done by Monday, okay? You'll be getting another assignment on Monday. Thanks for watching. I know this was long. I'll see you next time.